Welcome back to N's Notebook LM. Today, we're going to take a journey right into the mind of Albert Einstein to get our heads around one of the most profound, most reality-bending theories ever conceived, relativity. And the best part? We're going to do it using the simple, brilliant thought experiments from his own book to see exactly how he tore up the rulebook on our everyday understanding of space, time, and gravity.
You know, the cool thing is, right from the very beginning, Einstein wanted everyone to get this. He wrote this book because he believed you didn't need to be a math genius to understand the universe. All you needed was a little curiosity and the willingness to question what seems, well, obvious. So that's exactly what we're going to do.
All right, so here's where it all begins, with this one single question. And it might sound simple, but this question is the key that unlocks everything. It creates a total paradox, a head-on collision with what we think of as common sense. I mean, everything we know from daily life tells us that speeds add up. But what if there was one special speed, the speed of light, that just refused to play by those rules?
To really get why this was such a massive problem, you have to picture what was going on in physics back in the late 1800s. You basically had two sets of rules for how the universe worked. In one corner, you had Newton's laws of motion. They'd been working perfectly for centuries. And in the other corner, you had these new, powerful laws for light and electricity. And the two just wouldn't get along.
Think about it like this. If you're on a train that's going, say, 50 miles an hour, and you walk towards the front of the train, your speeds just add up for someone watching from the ground. Simple, obvious, right? That's Newton. But here's the kicker. Experiments were showing that if you shine a flashlight on that same train, the light zips away at the speed of light, c. And for the person on the ground, it's also moving at c. Its speed doesn't change one bit. It's just constant. How is that even possible? So now you've got this impossible contradiction. Light just refuses to follow the rules. Something fundamental has to be wrong. And this is where Einstein makes his incredible leap. He basically says, what if the speed of light isn't the thing that's weird? What if our ideas about time and space are what's broken? He proposed that maybe, just maybe, time and space aren't fixed. Maybe they're flexible, relative.
To solve this huge puzzle, Einstein did what geniuses do. He went back to the absolute basics. He asked a question so simple it's almost childish. What does it really mean for two things to happen at the same time? We totally take this for granted. We think now is just now, for everybody. But Einstein realized this assumption, this idea of simultaneity, was the first domino that needed to fall.
And he used a brilliant thought experiment to knock it over. Okay, picture this. You're standing perfectly still on a railway embankment, right in the middle of 2 points. At the exact same moment, lightning strikes both points. Because you're in the middle, the light from each strike travels the same distance to reach your eyes, and you see them at the same instant. You can say for sure those two things happened at the same time. Simple. But what if a train is speeding past at that very moment?
So for you, standing on the ground, it's a closed case. The strikes were simultaneous. But let's think about a passenger sitting right in the middle of that moving train. What do they see? Remember, the speed of light is the same for everyone, so we have to follow that rule.
Well, because the train is moving, that passenger is actually rushing towards the flash of light coming from the front and rushing away from the one at the back. So the light from the front strike has less distance to travel to reach their eyes. They will absolutely see the front strike first. For them, the events were not simultaneous. Two people, two different realities. And just like that, the idea of a single universal now is gone.
I mean, that realization is a total bombshell. It changes everything. But Einstein knew his work wasn't finished. This special theory, as it was called, only worked for steady, constant motion. It didn't explain what happens when you speed up, slow down, or change direction. And it completely left out the biggest force in the cosmos, gravity. To tackle that, he had to figure out what gravity really is. So, Einstein turned his incredible mind to gravity. And gravity had its own ancient mystery, a puzzle that goes all the way back to Galileo. Why does a cannonball and a small stone, if you drop them together, hit the ground at the exact same time? Why does gravity seem to affect everything in the exact same way, no matter what it's made of? To crack this, Einstein came up with what he later called his happiest thought. It's another amazing thought experiment. Okay, imagine you're inside a big sealed chest, like an elevator, just floating in deep space, far away from any gravity. You're completely weightless. Now, imagine a rope is suddenly attached to the top and starts pulling the chest upwards, accelerating it constantly. Suddenly, your feet are pressed to the floor. If you drop a ball, it falls. It feels exactly like gravity. Here's the question.
From inside that box, could you tell the difference? Is there any experiment you could do to prove whether you're sitting still on Earth in a gravitational field or accelerating through space? Einstein's answer was a resounding no, and this led him to a profound idea he called the equivalence principle. The effects of gravity are completely indistinguishable from the effects of acceleration. They are, in a very real sense, the same thing.
So if gravity and acceleration are two sides of the same coin, then what is gravity? What's actually happening? And this is the core of his general theory of relativity. Gravity is not a mysterious force pulling things across empty space. Instead, he said that massive objects like the sun literally bend and warp the fabric of space-time around them. An orbiting planet isn't being pulled by the sun, it's just following the straightest possible path through that curved, warped space. It's like a marble rolling around a bowling ball that's been placed on a trampoline.
Now, once you start thinking of gravity as the shape of space-time, that has some absolutely mind-bending consequences for the whole universe. Because if the sun can curve the space around it, then all the stars and galaxies and matter in the universe must be curving the entire cosmos. It means the universe itself has a shape.
This is a little tricky to visualize, so let's use an analogy from Einstein's book. Imagine you're a little two-dimensional creature living on a huge flat sheet of paper. For you, a straight line goes on forever. Your universe is infinite. But now, imagine you live on the surface of a giant sphere. If you walk in what feels like a straight line, you'll just keep going, and eventually, you'll end up right back where you started. Your universe is finite, it has a limited size, but it has no edge, no boundary you could ever fall off of.
And that's just one part of this incredible legacy. When you step back and look at it all, you see how it all connects. He taught us that space and time are not separate things. They're woven into a single fabric called space-time, that the speed of light is the ultimate speed limit in the universe, that mass is just an incredibly concentrated form of energy. That's E equals mc squared. And maybe most beautifully, that gravity isn't a force pulling us down, but it's just the shape of a universe we're moving through.
So from asking a simple question about what at the same time means, all the way to describing the possible shape of the entire cosmos, Einstein's thought experiments show us that the deepest truths are often found just by questioning our simplest assumptions. It really makes you wonder, doesn't it? What common sense ideas that we believe right now will be the next to fall? If this topic has captured your interest and you'd like to dive deeper, the book is called Relativity, the Special and General Theory by Albert Einstein.